welcome back. We're going to be working on section 10.3 today, which is talking about permutations and combinations. And we're going to talk about some guidelines on how to decide which one to use and how to know which ones to use. So when we're talking about counting problems, which we've been talking about on the first two sections, permutations represent the number of things n taken r at a time. So for example, if there are a deck of cards, you've got 52 cards. So if I deal out 5 cards at a time, how many combinations of the different cards could I get? So there are 52 things and 5 at a time. So a permutation would be, the n would be 52 and the r would be 5. Some other examples, if I had 10 numbers or 10 digits and I wanted to come up with 3-digit numbers, so the permutations would be, the n value would be 10 and the r value would be 3 for 3-digit numbers. So that's what we're looking at when we're talking about permutations. In permutations, we're trying to figure out how many different arrangements of the numbers that we can get. So we have a formula for permutations that involves factorial, which we learned, and the number of permutations, or the number of arrangements of n distinct things taken r at a time, and we're always assuming that r is less than n because we can't take more than we've got, is calculated by doing n factorial divided by n minus r factorial. So let's look at these. So I have 5 things, and I want to figure out how many combinations of 3 things can I have. So using my formula, for the first example here, we're going to do n factorial, which is 5. So we're going to have 5 factorial. And we're going to divide that by 5 minus 3 factorial. And we'll go ahead and look at this example and we'll keep going. So on this one, we're going to take 6 factorial and we're going to divide it by 6 minus 6 factorial. So again, what I'm saying here is that I have 6 items and I want to take 6 things at a time, and I want to know how many different combinations can I get. So if I go through and do my math on this, the 5 factorial would end up being 5 times 4 times 3 times 2 times 1, and 5 minus 3 factorial, 5 minus 3 is 2, so it would be 2 times 1. And so we would end up doing 5 times 4 times 3, which is going to be 20 times 3. So the number of possible combinations is 60, or permutations is 60. On the second example, we have to remember that 6 minus 6 is 0, and 0 factorial is 1. So what we end up with here is that this is just 6 factorial as our answer, divided by 1. And so our answers are going to be 60 for the first example and 720 for the second example. So let's look at another case. So in this situation, how many ways can you select 2 letters followed by 3 digits for an ID if repeats are not allowed? In other words, I can't have 2 A's next to each other or 2 B's next to each other or something like that. So here's what we're trying to do. There are 26 letters in the alphabet. So we're trying to choose combinations of 26 letters, and we're doing a permutation, and we want 2 letters each. And so permutations do not allow repeated numbers. And then we're going to take 3-digit numbers, so we have 10 digits to choose from, and we want to choose combinations of 3. So if we do the calculations for the first two permutations, we're going to get 650 for the first one. And for the second combination, we're going to get 720. And so the total number of combinations of those two things is going to end up being 468,000 possible combinations of these symbols. This is another one. How many 4-digit numbers can be written using the numbers from the set 1, 3, 5, 7, and 9? So it says here repetitions again are not allowed. So that's one of the information pieces with permutations that we always have to look at. So there are 5 sets in my 5 numbers in my set, and I'm looking for 4-digit combinations of those numbers. So we're looking at the permutation with 5 digits, and I want combinations of 4. So if I plug that into my formula, 5 factorial divided by 5 minus 4 factorial, that's going to end up being 120 different combinations of numbers. Okay. So again, since repetitions were not allowed, that was important. And the order is important. And the reason we say that is because the number 135 is not the same thing as the number 351. So let me say that again. Order is important is because the number 135 is not the same thing as 351. But those two numbers are using the same combinations of digits. And it's supposed to be a 4-digit number, so we can put another digit in there. And I'll put a 2 on the end. But again, it's the same thing. The number 1,352 is not the same thing as the number 3,512. So order is important in the sense that it is not going to affect. I need to look at all those possibilities in coming up with those combinations. Okay, so then we get into something called combinations. Okay, so combination is a little bit different. And a combination, the symbol that we have down here, is red, N, choose, R. So we want N things that are R at a time. But in this case, the order of the elements does not make a difference. So these are called combinations. So committee members would be a good example here. Like if we had a club and we wanted to figure out the committee members of the club. So who's in the club, who's on the committee? If I have person A, B, and C, or if I have person B, C, and A, they're all on the same committee. So it doesn't really matter whether I list them as A, B, and C, or B, C, and A, they're still the same person. So what we are looking at here is that with combinations, we have to sort of eliminate those overlaps or those duplications, and so that the combinations will be smaller than the permutations. So the number of combination or subsets is another way of looking at it, of n things taken r at a time, and we end up with a little bit more involved formula, because remember what I said, we have to take the number of permutations, which are all the possibilities, but we have to take away those overlaps. We have to take away those duplications, so to speak. So we've got this a little bit more complicated formula, but here's our formula for combinations, where we are taking the permutation formula and we are dividing out that r factorial value. So let's look at this. So we have 5, choose 3. So we're going to use our combination formula, And we're going to take 5 factorial, and we're going to divide by 3 factorial. That's our R value. And then we're going to divide by 5 minus 3 factorial. So we end up with the 5, 4, 3, 2, 1 on top. And on the bottom, we have 3, 2, 1. And then 5 minus 3 is 2, so we end up with 2 and 1 again. Oops, excuse me, that should be a 1. I'm just going to scribble it out and put a 1 there. So then if we cancel out our duplications here, we've got the 1, the 2, and the 3. So we'd end up with 20 divided by 2, which is 10 possibilities. Do the same thing here. I have 6 things and I want 6 items in the 6 choose 6. So if you think about that, if I have 6 items and I want to choose 6 things from the 6 items, there's only one possibility for how that can happen. So we're going to see how that works out here. And then we have 6 minus 6 factorial. And so if you notice what happens here, remembering again that 6 minus 6 is 0 and 0 factorial is 1, we end up with the 6 factorial and the 6 factorial canceling out, and we're left with one possibility. So again, you'll notice that these two numbers are smaller values than the permutations because we have to eliminate that overlap. We have to eliminate the extra values in the permutation. So here we have another example. Find the number of different subsets of size 3 in this set. So again, we're looking at this, that there are 9 possibilities in the set, and we want 3. So we want 9, choose 3. So we're using our combination again, and we're going to put that into our formula. So we have 9 factorial divided by 3 factorial, and then 9 minus 3 factorial. So if we do our mathematics for that, which I'll let you do the math for it, we should end up with 84 possible combinations. So again, what that means is that there are 84 different combinations of the word, of the letters MATH, ROCKS, to put it into subsets of 3. What we have here also, another note, repetitions are not allowed. Again, that means that I can't have the letter M 3 times or the letter A 3 times, or I can't have MAM or something like that. And it has to have 3 distinct elements, and order is not important in this situation. Okay, so here we have an example. Form of poker is 5-card poker, so 5 cards each, dealt from a deck that has 52 different cards. So how many different 5-card hands are possible? So again, since there are 52 cards in the deck, I have 52 to choose from. So it's 52, choose 5. So I have 52 cards. I want to choose 5 cards from that deck. So how many possible different hands could I draw? So we would have 52 factorial divided by 5 factorial and 52 minus 5 factorial. So the number of possible combinations of hands that I could come up with would be 2,598,960 different combinations. Okay, so let's look at this. To sum it all up, here's what we have. Permutations and combinations. Both of them, the number of ways, you're looking at the number of ways to select R items, R combinations out of N items. So we have N things, and we want R items out of there. So 52 cards, 5 in my hand, or you know, again, 10 digits, and I want a 3-digit number or a 4-digit number. In both of these cases, repetition is not allowed. I can't repeat a digit, or I can't repeat a card. I can't draw a card if it's already been drawn. So repetitions are not allowed. The third one can get a little confusing. Order is important for permutations. In other words, I do need to worry about the fact that 476, if I'm looking at that 3-digit number, is not the same thing as 746. So I need to count both examples as 2 different cases with a permutation. But with combinations, the order is not important. In other words, I'm going to look at the number 476, and I'm not necessarily looking at numbers here, and I'm going to look at the number 746 as being the same thing. So if you think about decks of cards, if I drew a 4, a 7, and a 6, that's the same hand as if I drew 7 and 4 and 6. So I don't want to count all the combinations. I want to eliminate the overlaps. So that's why our formula changed some. So what we're looking at here is with permutations, we're looking at the arrangements of N items taken R at a time. Whereas with combinations, we're looking at a subset of N items taken R at a time. Here are formulas. So this is a really good sum up page to make sure you're comfortable with it, so you have this for your test. Some clue words for permutations are the word arrangement, schedule, order, and some clue words for combinations are group, sample, selection, subset. Those are some words to pay attention to in the problems to decide how do you know whether to do a permutation or a combination. I hope this helps, and I'm still working on getting the videos set up, so we'll keep working on that. Have a great day.